Hi guys, welcome back to the channel. So today we are going to be discussing about today's lead code question, which is find the duplicate number. So we are given an array of nums, and then we will contain the elements which are present in this particular nums, and then the integers present in this particular range will be from 1 to n, and then there is only one repeated array with only one repeated number which is present in the nums, and then we should return this particular repeated number. Suppose if we take this particular example, here we have 1 3 4 and then 2 and then 2. For this the repeated number is 2, so we need to return this. And then for this we have 3 as repeated number, so we are going to return this particular 3. And then here as well we have 3 as our repeated number, so we are going to return this particular 3. So for this, if we want to check whether the particular number is repeated or not, so we are going to see the four approaches. The first approach is, suppose let's say this is the element, and then we need to check whether this particular element present other than this particular index. So for this I am going to travel again all the array, and then I am going to check. So and then again for 3 I am going to check, and then 4 I am going to check for the forward, and then 2 I am going to check the next indexes. So for this it is going to take for I for each index, and then for j it is going to take for the forward, and then this is going to be my index. So for this it is going to take big O of n square as time complexity. The brute force approach will be big O of n square. Suppose if we do not want to use big O of n square, can we do it in n log n or n time complexity? So let us see. Suppose let's say this is the array. Now if we sort this particular array, then it becomes like 1 2 and then 2 and then 3 and then 4. So if we see, we can check the particular number, whether this particular number has the same element which is adjacent which is adjacent to this particular index. So it has this particular index, so we are going to return this particular number. So that is how we are going to do. So we are going to sort and then check whether we have any number which is adjacent to same number, and then we are going to return the answer. So this is going to be one more approach. First it is going to take big O of n square, which is two for loops, and then for this we are going to sort and then check, and then again we are going to use one more thing, which is we are going to use the map, so that it will store the, either we can use map or array to store the frequency, So suppose let's say we have this particular array, then I am going to increase the frequency of all the elements which are present in this particular array, and then whenever I see an element having more than one frequency, then I am going to return this particular answer. So for this it is going to take big O of n, and then space it is going to take big O of n. So here it is given that we should not modify the array, and then we should only use extra space. So this extra space we need to optimize this. So let us see. Suppose let's say if we can modify this particular array, can we come up with any solution? So let us check that. So this is our example. Now we'll try to modify this solution. We'll try to modify this array and then check whether we can arrive at particular solution. So for this, if we take the indexes, then it is going to be 0 1 2 3 and then 4. Now as it is given that it will be ranging from 1 to n, then I can map all the numbers which are present in this particular array to each particular index. Suppose let's say if it has 1, then I am going to map it to the index 1, 0. Then it is 2, then I am going to map to 1. And then if it is n, then I am going to map to n minus 1. So whenever we come up with any number, then we are going to have, we are going to put this particular number into this particular index, and then whenever there is a collision, like the number minus 1 has the same number and then the other index also has the same number, then at that particular point we are going to return this particular answer. So let us see the solution for this. Otherwise we can go through one more approach where we have this particular array, and then we need to check whether this array has, we need to give the answer for this particular array. So we have 3 as our answer, but we need to find in a different way. So let us think this particular array in terms of linked list. So if we take the indexes, then it is going to be 0 1 0 1 2 3 4 and then 5. So let me take this particular example with the array with the linked list. I'll start from here and then I'm going to consider slow pointer and then fast pointer. I'll tell you why we are going to use the slow pointer and then fast pointer. Let us go through this particular num_i. Now we are going to start from 5, and then after 5 we are going to go from here this particular index to 5, which is going to be 3. So this will go for 3, and then 3 is going to, from here we are going to come to the 3 index, which is going to be 4. This is going to be 4, and then after coming to the 4 we are going to come back to the index 4, which is going to have the element of 2, and then after 2 here we are going to have the 4, and then we are going to come back to 2, and then after 2 we are going to come back to the 3, and then this is going to be 4 and then 2, and then again we are going to say that this is going to be my element. So this is going to be like the cycle in the particular linked list. So as we can see that this particular linked list has a cycle, then we can find that we'll have the collision when we take the slow and fast pointer. Suppose if I take slow and then fast as here, and then here there is already collision, but we'll move at least one iteration. So this is going to be slow here, and then the fast is going to be here, and then for again one more step the slow is going to be here, and then fast is going to be here, and then for one more step the slow is going to be here, and then fast is going to be here. So after this particular case we are going to have the collision where the slow and then fast becomes the same, which is at this particular index at this particular 2. Now after coming to here we need to find the node which is present at the start of this particular linked list. For that I'm going to start the slow or fast pointer from here again, and then I'm going to travel till again one more collision happens at this particular index. So I'll tell you why we are going to consider this particular condition where we have, like, after getting the collision, why we are going to start the fast and then slow. Fast is going to start from the start of the linked list and then slow from here itself. Suppose if we take the slow and then fast pointer, the slow is going to travel x plus y. So let us think that we have this as our this is our x, and then the collision path is y, and then this particular total is c. This is going to be c. So for that we are going to say that this is going to be my x plus y, the distance traveled by the fast pointer, which is going to be x plus y plus some number of cycles. So this is going to be number of cycles we had traveled. Suppose if we take this particular example where we have x into 2 into x plus y equal to x plus y into n into c, then it is going to get like x plus y equal to n and then c. Now if I want to get back to the start of the cycle, so if I want to get back to the start of the cycle, which is from here to here, then if I had already traveled y, then I need to travel this particular length. So if this particular length is some z, then that z is going to be at least x. So let me show how. Suppose let us take n equal to 1. Then it is going to get like x plus y equal to c. Then the distance required to travel to the c will be x plus y equal to c. So now I had already traveled y. So the extra thing which I need to travel so that I'll cover the total c is going to be x. So that's why we are going to say that this particular distance is going to be x. This particular distance is going to be x. But we are taking n equal to 1 for simplicity. It can be 2 or 3 depending upon the situation. So at this particular time we are going to have this particular collision and then we are going to return this particular answer. So let us go through the solution for two implementation. So the first implementation is going to be like we are taking the indexes and then we are matching the indexes based upon 1 to 0 and then 1 to 0 and then 2 to 1 and then n to n minus 1, and then when there is a collision then we are going to return the answer. Suppose let's say we are taking this particular solution and then if we have this num psi and then if it is not equal to I plus 1, that means suppose if we consider this particular one and then this is not equal to I plus 1, so this is going to be 0 plus 1 equal to this, so this is same. So we are going to get back to next element which is 3 and then now we are going to compare num psi which is 3 and then 3 plus 3 equal to 1 plus 1 which is going to be 2. So this is different. So that's why we are going to map this particular element with 3 which is going to be 1 and then 2. We are going to map to this particular array. So we are going to swap and then we are going to do till one of them will be matched, and then after that we are going to check this particular nums of I minus 1 will be equal to nums of I, and then let's say if both are equal, both the numbers which are present in this particular indexes are equal and then these particular indexes are different, that means we will have two indexes and then those two indexes values are same but the mapping which the indexes are different, then we are going to say that this particular number is repeated and then we are going to return this particular number. So that is the first solution where we are going to modify and then we will not be using any extra space but we are modifying the array. Suppose let's say we are taking with the linked list where we have slow and then fast pointer. So here we are going to use the do while. So if we use while operation, we cannot write the condition. Why? Because slow and then fast is going to be the same. Suppose you might think that we can give nums of the fast as nums of 0. Then if we give that particular solution, there can be one case. Suppose if we take this particular case, then nums there will be some case where there will be a collision and then both will be same. For that it is going to that's why we are going to will not be taking this. So we are going to say now slow equal to nums of slow and then fast is going to move towards twice, and then the while we are going to write till both of them will be equal, and then we are going to start the fast from the starting of the index, and then till it becomes the slow becomes the fast, then we are going to move the pointers, and then at last we are going to return the answer. For this, the time complexity is going to be big O of n, and then space complexity is going to be big O of 1, and then we are not modifying the array. Yeah, that's all for this video. Thanks for watching the video.